All right, so last time we went in and we started introducing the idea of elasticity. So what we said last time was, we know, in fact, all the demand curves that we have drawn up until this point in time in your notes have all looked exactly like this. They've all had a nice downward sloping 45-degree slope to them. And so, and that was good enough to do the analysis of how does the quantity demanded change when price changes? We know that's a negative relationship. What are all the different factors that will shift the demand curve in one direction or the other? Determining equilibrium in the market, shortages and surpluses, and all those other types of things. All right. But last time in chapter 6, then, we looked at this and asked the question again, how does the quantity demanded change when price changes? Because I asked the question, or actually made the statement, that if we can all agree that this is a downward sloping demand curve, then we can all agree that this is a downward sloping demand curve, and this is a downward sloping demand curve. Thus, everything in between, those are also downward sloping demand curves. So the question ultimately is, with elasticity, is there going to be a strong or is there going to be a weak response to that change in price? So the way we set it up last time was, we went in and said, well, look, what if we go in and we have a relatively shallow demand curve? It's not very steep at all. And if you go in and in your notes, you can show that if we go in and we change the price even by a very small amount, the quantity demanded is going to change by a very large amount. So if that was the case, we said that this demand curve is relatively elastic in nature. Elastic, meaning there's a strong response to a change in price. Whereas if you go to the other extreme, where the demand curve is very steep in nature, and you go in and you change the price by the same amount as we did in the one in the top, what you find is that the quantity demanded actually changes by a very small amount. And so if that is the case, then we call this demand curve inelastic. And again, I said, when you hear the term inelastic, I want you to think that there has been a weak response to a change in price. Okay, so that was a very basic idea of this entire thing. So then we went in and said, all right, now that we kind of have the idea of what we're looking at here, we want to do more than just look at the curve. We want to be able to, number one, quantify how people are actually responding to this change in price and be able to compare those numbers across goods, right? So we can look at good A, good B, and good C and be able to make some sort of statement about how elastic or inelastic each one of those goods are relative to each other. So we started out with the idea of taking just a very simple equation, the percentage change in the quantity demanded divided by the percentage change in price. So this is the formula that you use if the percentage changes are actually given to you. You have two of those in your notes. So we went in and we plugged the numbers in. So sometimes the price goes down, quantity demanded goes up. Sometimes the price goes up, which means the quantity demanded is going to go down. Either way, we came out with a negative number, right, that came out of both of those calculations. But then, to get rid of the negative number, what did we do? What's the very last step of every elasticity calculation? Absolute value. Very good. So when you take the absolute value, that gives you your final number for the elasticity of demand. And thus we went in and we interpreted that as meaning if the number that you get after you take the absolute value, if that is greater than 1, then we say demand is elastic. Thus, the larger the number, the more responsive people are to that change in price. If the elasticity of demand is less than 1, then we say it's inelastic, and thus the smaller the number is, the less responsive people are to that change in price. All right, so that's how you go in and actually interpret the numbers that come out of the elasticity calculation. All right, So that's the formula you use if you already have the percentage changes in front of you. All right. Then I said, well, here's the problem though. Number one, most of the time we do not have the actual numbers in front of us. We have, demand curve numbers that have prices and quantities. And then the other problem that we're about to run into is that we have what we call the unit problem. So in other words, and you notice in this particular case, when I went in and I actually put the quantity of this particular good, you notice I didn't say what good this was or how this good was being measured, right? Whether it's tons, feet, yards, right, what have you. I didn't give you any units to this whatsoever. I'm going to in just a little bit to show you how that next equation is actually going to help us out in a couple of different ways. So what we did was I gave you this particular data and I said to use this data to calculate elasticity, we're going to use this arc elasticity formula right here. So we're going to take the numerator up here, calculates the percentage change in quantity. The denominator down here calculates the percentage change in price. And again, not only will it calculate the elasticity value, but it will also, and use the same rules, right, to determine whether it's elastic or inelastic. But it also goes in and takes care of what we call the unit problem as well. So, so even if I've had some people argue, well, what if I know how to calculate percentage changes with these numbers? And that's all well and good. What's going to end up happening though is you can calculate the elasticity of demand for one good, let's say milk that is measured in gallons, and you can use those percentage change formulas to calculate elasticity for, let's say, natural gas that's measured in cubic yards. But the problem is those numbers are not going to be comparable because they do not cancel the units out. So this formula, whether you see it within the mathematics or not, actually cancels the units out. And so it doesn't matter what good you're actually calculating for. I'll show you an example of that here in just a moment. All right. The other thing that I said was when you go in and you get an elasticity of demand number, let's just say that happens to be a positive 3.4. In this case, 3.4 is greater than 1, so you would say that demand is elastic. But I also said that there are no units that are attached to this at all. So in other words, the elasticity of demand is not a dollar value. Notice there's not a dollar sign here. It is not a percentage, so there's no percentage here. That gets canceled out in the formula itself. And I think this is important. Elasticity of demand is not the slope of the demand curve. It is not the slope of the demand curve. Now, I think that's worthwhile to point this out because, and I understand the reasoning, when you go in and you look at this demand curve, you say, well, this demand curve doesn't have nearly the slope to it that this demand curve does. And so therefore, is an elasticity actually calculating the slope of the demand curve? And I get the idea of why people would go in that direction. But the answer is no, it's not. And believe it or not, you actually went in and proved this to yourself last time. How? All right. Well, we went in and we had this price and quantity data last time, which, by the way, if you actually go in and you had a piece of graph paper, you would be able to go in and graph each one of those points, price and quantity. And what you would get is some straight line demand curve looking something like that, right? Whatever shape it might actually be. All right. The one that we worked out in class together, I said that price, what was it, increased from $1 up to $1.20. That's in your notes. So that's the one that we went in and we calculated together. And we found out that in this part right here, I believe we got an elasticity of demand that came out of it of 0.58, correct? So we said that in that particular case, demand was inelastic. Okay. The one that you did as an in-class quiz last time, I said I wanted you to calculate the elasticity if price started at $2 and declined to $1.80. And what you found out last time was when you did that calculation, the elasticity of demand was actually 1.73, right? So that's the calculation, or those are the calculations we did last time. Now, let's go back to this demand curve for just a moment and go back to elementary algebra for just a second. If you go in and you just look at slope as rise over run, then if you go in and you calculate the slope of this line between these 2 points up here, and you calculated the slope of the line down here between those 2 points, what do you know those two numbers are going to equal? What do you know is true about those two numbers? I'm not asking for a value, but what do you know about the slope up at the upper end of that straight line and the slope at the other end of that straight line? Oh my God, the math department is not doing their job. They're the same. Very good. Doesn't matter where along a straight line, doesn't matter what the units are. Along a straight line, if you calculate the slope of that line, the slope between any 2 points is going to be identical along that demand or along that straight line. All right. Well, I want you to notice then when we calculated elasticity, it showed that down here from $1 to $1.20 down in this area, demand was inelastic. And it showed at the upper end of the demand curve that demand was actually elastic. So you went in, you took 2 different points, $1.80 and $2. Down here, you took 2 points, $1 and $1.20, and you got 2 different numbers, right? That actually came out of it. So that in and of itself right there proved that elasticity and slope are not the same thing. Okay, so the question then becomes, all right, well, first of all, why does, if we have a straight line demand curve, why is it that elasticity actually varies along any demand curve in the first place? And the answer to this actually comes from the idea that we are actually calculating percentage changes. And I think that throws a lot of people. In normal life, we're used to going in and dealing with absolute changes quite a bit, but we're really not used to going in and thinking about things in a percentage change sort of environment. So there's an idea in economics called the price to income ratio. The price to income ratio. And basically what this statement says is, if you go in and you have a percentage change in a higher priced item, that is going to impact your income more than a percentage change in a lower priced item. Therefore, if it impacts your income more, then you are going to go in and be more responsive to it. All right, that's what the price to income ratio actually says. Now, in reality, when you go in and you look at this from a percentage change point of view, what exactly does that mean? All right, let's go in. Let's just take a very, very simple example. We have the absolute change in income, and then we're going to have the percentage change in income in our second column. All right, and let's just go in again, very, very simple numbers. Let's go in and start with $1. So right now I have a dollar in my pocket. If somebody walks by and they give me another dollar, so now I'm standing there with $2 instead of $1. What has been my absolute change in income? How much more money do I have now? $1, right? I went from $1 up to $2, my absolute change has been $1. What has been my percentage change in money? If I had $1 and now I have $2, what's my percentage change in money? It's not that early. If you double something, what's been the percentage change? 100%. Very good. So if you go in and you double something, then there has been a 100% change. Okay, very good. That makes sense? All right, but let's work this problem in reverse. Let's say I'm standing here with $2 and my wife comes by and takes $1 from me, and now I'm only holding $1. Which, by the way, is hypothetical in nature. If my wife came by and took money from me, I would be holding nothing, right? But that makes the problem more, so that makes the problem a little bit harder. All right, so I start out with $2. Somebody takes $1 from me. What has been my absolute change in money? It's still $1. Very good. I started out here with $1. I went up to $2, so my money changed by $1. I started out with $2. Now I only have $1. My absolute change is still $1. But now, what is my percentage change in income? Actually, no. It's 50. There you go. It's a 50% change. Think of it this way. If you double something, that means you've increased it by 100%. But if you halve something, it is a 50% reduction, right? You have to. So that's a 50% change. My point is this: the absolute change in both of these has been exactly the same, but the percentage changes are different, right? Depending on which way you are actually going. So you have to think a little bit harder about the percentage changes and thus how that actually affects the absolute change, and thus how people will actually respond to this, to the change in price of this good. Now, let me go in. Let's take a very simple example to show you how this works. So let's go in. Let's say this happens to be the market for gasoline. We have a downward sloping demand curve, which includes all possible prices of gasoline, going all the way from 0, right? It's free, all the way up to whatever, $1 million a gallon. Okay, so if we go in, let's go to the very bottom of this demand curve, where price is 50 cents per gallon. All right, so at 50 cents per gallon, if you draw this line across as straight as you can where it strikes the demand curve, there is going to be your quantity demanded, however many thousands of gallons that might be. Okay, now I'm going to work this problem a little bit different. I'm going to use percentage changes this time. So let's say right now we're starting at 50 cents a gallon, and the price of gasoline increases by 10%. Well, can anybody tell me what is 10% of 50 cents? 5 cents. There we go. So my absolute change is going to be 5 cents per gallon. Is everybody with me? So the price of gasoline is now going to go from 50 cents per gallon up to 55 cents per gallon. So when you go in, you draw this line over where it strikes the demand curve. I want you to notice, yes, the quantity demanded went down, but it was only 5 cents. So it really didn't go in and impact people's income that much. And so therefore their behavior really didn't change all that much either. All right, but let's go to the upper end of the demand curve and see what happens. So let's go up here and start out with a price of $1.50 per gallon. Let me use a different color pen so you can see it a little bit better. Maybe. All right, so at $1.50 per gallon, if you draw this line across where it strikes the demand curve, There is our quantity demanded at the higher price. I'll just call it Q1 again. But in this case, I'm going to increase the price of gasoline by the same 10%. So now the percentage changes are the same. But again, can anybody tell me what's 10% of $1.50? 15 cents. So our absolute change in price is going to be 15 cents per gallon. So now the price of gasoline goes from $1.50 all the way up to $1.65 per gallon. Well, if that price jumps all the way up to $1.65 per gallon, look what happens to people's behavior, right? There's Q1. Their quantity demanded decreases by a much larger amount. So thus, what you end up with in this particular graph is that down at the lower end of the demand curve, lower end of prices, it really doesn't change people's price to income ratio. So therefore, they don't respond very much to it. So you have inelastic demand, which is down here. If you go to the higher end of prices, which is going to be up in this area, people respond more to the same percentage change in price. Therefore, we have elastic demand at the upper end of the demand curve, which is exactly what we showed in this graph over here. So this actually explains a lot, by the way, because when you go in and you look at the types of items that businesses generally tend to run sales on, normally they are not low-priced items. So if you were to walk into Walmart, for an example, and they went in and they had a 25% off sale on ballpoint pens, right? Do you think you're going to get run over by people heading to the office supply aisle to buy ballpoint pens? And the answer is no, right? Because what's going to end up happening is if you're in the area, some people might want, unless you need them, right? You're not even going to respond to that. Because you can buy an entire package of pens for what, $1? So you're going to save a quarter, right? If you do that, it's not going to make that much difference whether you do or don't take advantage of that. But if you go in and you often see people or companies run sales on like cruises or automobiles, right? Things like that. So if you ran a 25% off sale on an automobile, then that is going to be literally tens of thousands of dollars off of a $35,000 automobile. That's huge, right? And that's enough to go in and change people's behavior. Travel, furniture, all those very large items, they're constantly tinkering with this price because they're very large dollar value items to begin with. It makes a difference then whether you buy that item now while it's on sale as opposed to not. And people go in and they change their behavior radically because of that. So that's why you see sales being run on very, very high priced items and not very low priced items. Okay, so not only can a particular demand curve actually be relatively elastic or inelastic, but you can also go in and you can have elasticity ranges along a given demand curve as well. Okay, so questions about the idea of the price to income ratio. So that's why we go in and we don't have any units attached to this, and that's why we actually see different elasticity values along even a straight line demand curve itself. All right, very good. The other thing that I do want to point out, again, slope and elasticity are not the same thing, but I do want to point out the unit problem as well. Because this is something that I don't think people really think as much about as they really need to. Because again, when I go in and even the numbers that I'm going to give you on a worksheet that I'm going to hand out today, they actually have no units attached to them whatsoever. And there's a reason for that. And so here's the problem that you get into if we actually don't go in and we don't deal with this unit problem itself. All right, first of all, I want to apologize. I can't get my graphs on this particular paper the way I want to. So I'm going to go ahead and draw the graphs by hand. But I want to go in this particular case, I think this is even more interesting because we're going to go in and not just compare two different goods like natural gas and milk, right? I don't even want to go that far. I'm going to take exactly the same good, hamburger, and then I'm going to measure a hamburger in pounds, and then I'm going to measure it in ounces and see what the difference in the units happens to be between those goods. All right, so let's go in and let me draw the situation. So we have hamburger, which is going to be measured here in pounds. And then in our second graph, we're going to have hamburger measured in ounces. Price, and then this is in ounces. Okay, both of them are going to exhibit a normal downward sloping demand curve, right? That looks something like that. And let's start out in our first circumstance, where if it's measured in pounds, we're going to go in and start with the price of $3 per pound. And at $3 per pound, when you draw this line over, let's say people are going to be willing and able to buy 5 pounds of hamburger at that price. Okay, now what we can show is if the price of hamburger goes down, and let's say it goes down to $2, the quantity demanded of hamburger is going to increase up to 10 pounds of hamburger. Okay, very simple case to work out. But I want you to notice, now let's go in, before we do the math, let's go over to the ounces side and do exactly the same thing. So we have the same exact hamburger. The initial price of that hamburger is going to be $3 per pound. And at $3 per pound, people are going to be willing and able to buy 80 ounces of hamburger. By the way, 80 ounces is exactly the same thing as 5 pounds, right? It's exactly the same situation. Now, the price of this hamburger is going to go down to $2. And when price goes down to $2, quantity demanded increases up to 160 ounces of hamburger, which again is exactly the same as 10 pounds of hamburger. So for all intents and purposes, these are exactly the same demand curve. Is everybody with me? All right, I want you to notice something. If I go in and I measure the slope of the first curve measured in pounds, slope is rise over run. And in this particular case, since we don't have X's and Y's, the change in your rise will be the change in P divided by the change in the run, which is going to be your change in Q. So it's actually delta P, delta Q that is going to be in those numbers. Okay. Anyway, it's your basic slope formula that you learned in elementary algebra. So I went in, I took the slope of that first demand curve, and I came out with a negative 1/5. All right, so that's what you would get if you did this in elementary algebra. Now, if I go over to that second demand curve, which is essentially exactly the same curve, it's measured in different units, and I go in and I plug those numbers into my slope formula, look at this, I come up with a different number, right? A negative 1/80. And the fact is, none of these numbers can be reduced to make it look like the same curve, right? It's exactly the same graph. So that tells you right there that just taking the slope of a demand curve and using it as an elasticity number will absolutely not work, right? And this is with the same good, let alone if you're talking milk on the left and whatever, natural gas over on the right-hand side. So slope will absolutely not work. So then what I did, I went in and I did the same exact calculation, only I used our arc elasticity formula, just like we did in class last time. So I took these numbers, P1 minus P naught divided by Q1 minus Q naught and so on. I plugged those into my formula. I worked it all out, took the absolute value, and came out with an elasticity for pounds of 1.67. Then I went in and used exactly the same formula, only now I used the ounces numbers to go in and plug in for my P's and Q's. And lo and behold, look what happened. By the time it's all done, take the absolute value, I come out with exactly the same number. So not only does this take away the slope concept, but it takes away the unit problem as well. So I can take anything, pounds, ounces, yards, feet, whatever, no matter what good it is. If I use that arc elasticity formula, the elasticity values that I get are comparable with each other across time. Okay, so even though this is a very nasty formula to use, this is the only way that we can tackle both of those at the same time. Okay, so there's your proof. Why not take my word for it? There's your proof that we can go in now and we can use this formula, and regardless of what those goods are, we can go in and we can compare them to each other. All right, any questions about the arc elasticity formula and the units, right, that are involved and not involved? Okay, very good. Let's go ahead then. And so the question becomes, we don't know how to calculate it and how to put it in and how to interpret the actual number. So the question becomes, what determines it? Where do these, why do people go in and respond the way they actually do? Well, it turns out, there are a number of different, reasons why people will, change their behavior or not change their behavior as the price changes. And we could actually spend a couple, 2 or 3 class periods talking about those different things. I think that's going a little bit too far with this, because in my mind, you can look at 2 determinants of elasticity. And personally, I think that these 2 things explain probably 90% of human behavior and why the elasticity numbers are actually the way they are. All right, so the first determinant of elasticity is what I call the nature of the goods. So in other words, when you go in and you look at 2 goods, if they're relatively similar goods, you can actually go in and you can look at them one of 2 ways. You can go in your mind and you can view them as necessities. And a necessity type good is one of those things that you just really can't do without. And so if you view it as a necessity type item, then it is going to have very inelastic demand. So as that price changes, you're really not going to change your behavior very much to that change in price. On the other hand, though, you could, and by the way, necessity type items would be anything like food, clothing items, medications, things like that, electricity, right? All those types of things you would consider necessity type goods. On the other hand, you could actually view a good as a luxury good. And luxury goods are obviously something that you can do without. You may not like it, but you can do without it. And if that is the case, when that price changes, you're going to be very responsive to that change in price. So therefore, you get elastic demand that comes out of that particular good. So automobiles, boats, travel in general, jewelry, housing, things like that, those would all be considered luxury type goods. All right, I'll give you a couple of examples here in just a moment. The second determinant of elasticity is what I call the availability. of close substitutes. So if you go in and you have, you have a good, and if the price starts to go up and you start looking around for other things that you could consume, that is going to be a determinant of how responsive you are to the change in the price of that good. So in other words, if you go in and you have something like gasoline, for an example, gasoline has, I would argue, no close substitutes. Now, you can go in and make the argument, well, there are several different types of gasoline, right? You have 87 octane, you have 92 octane, you have E10. Now some of the cars use E85, right? Things like that. Well, you may have choices of gasoline, but when you're looking at gasoline, you cannot pour kerosene in your gas tank and your car run down the road, right? I mean, it's as simple as that. So really, you have to put gasoline in your car to get it to run. So there are no close substitutes. And so what we find in this case, if there really aren't any close substitutes, then that good exhibits inelastic demand. Inelastic demand. So the fewer the substitutes, the more inelastic that demand is going to be. Now, we've already talked about this actually when we were doing complements and substitutes on the demand shifters. What about cola products, right? Coke, Pepsi, right? So on and so forth. Well, I think we've already argued that there are actually many close substitutes. In fact, you can even go in, if you're talking about just going in and drinking something, you can even move out from cola products to, milk and tea and coffee and so on. Anything will go out and actually, substitute over into cola. So there are many, many close substitutes. So what we've already seen is, as the price of those goods go up, people are very responsive to it, and thus demand is elastic. The more substitutes there are, the more elastic the demand is. All right, so actually, I think those two, for the most, again, there are others, but I think for the most part, these two can actually explain a lot of the elasticity values that we see out there today. I actually have a list of these. I just want to go through a couple of them that I think are kind of interesting, and look and see, which categories they actually fall into, to see if we can actually, get an guess of what the elasticity might actually be. Now, just to give you an idea of where these numbers fall, we know that elasticity of demand values are always positive in nature. Now, I have not talked yet, I'm going to on Friday, but I have not yet talked about the idea of an elasticity of demand of 0. Right? You're going to see one of these on a worksheet, and it is actually in your book, right? So take a look at that. But you cannot have an elasticity of demand value that is negative. You can have it as 0, and it can get larger, but it cannot be negative. So we know in our interpretation of elasticity that if it's between 0 and 1, we say if it's less than 1, then it is inelastic. So this shows that the lower the number is, the less responsive people are. And if the number is greater than 1, then it is going to be elastic. And just to give you an idea, if you get an elasticity number that is 2 or greater, we consider it very elastic. So people are very responsive to that change in price. Right, so just to give you a flavor, right, of where these numbers actually fall. So I've written some of these down from, studies that I've run into and so on. Some of these I just think are interesting. Let's go in and let's look at automobiles. Automobiles, the elasticity of demand. All right, guys, take a stand. Are automobiles necessities or luxuries? Luxuries? You might not have a car, out of curiosity. I don't know. Is there anybody that would argue that they're a necessity type item? Now, there's no right or wrong in this, right? I want you to understand that there are some people that consider them necessities. If you've got a lot of kids, you live outside of town, right? Whatever the case might be, it changes it just a little bit. But a person can also argue, if you look at automobiles as a way of just getting from point A to point B, then are there any close substitutes for automobiles? And the answer is actually yes, there is, right? And walking has to be one, and has to show up on the list of one of them. So walking, bicycles, taking mass transit, riding a horse, riding a goat, riding a cow, right? Whatever the case might be. There are a lot of ways to get from point A to point B. So if we think they're luxuries, explain the elastic. If we think that there are really a lot of close substitutes for getting from point A to point B, you notice both of these are actually leaning towards the elastic side. Anybody want to take a stand? So we're up in this area somewhere. How elastic do you think automobiles actually is? Kind of, sort of, or very elastic? When the price of cars changes, how do people respond? You think very? And you would actually be right. We're running out of time here, right? I'm just going to put it as 2.24, right? So people are actually very responsive to that. By the way, this actually shows why you have a lot of car sales that are happening. And particularly when we're going into a recession, one of the first things economists look at is what's happening to automobile sales. And when those automobile sales start to slide just a little bit, those dealerships will go in, they'll start reducing the price, offer dealer pricing, free oil changes for a year, free gasoline for a year, anything to reduce the effective price of that car, because by doing so, they know people will actually respond to that. Here's I thought was another interesting one, movies. And this is actually going to the movie theater to watch a movie. Necessity or a luxury? Probably a luxury. I think the only person that might consider it a necessity is my brother-in-law, right? I think he's got to go like once a week, or used to before COVID. I think this is completely, blown his world view of things, right? Because he hasn't been to the movie theater in like a year. But I think most people would consider it a luxury. Availability of close substitutes. Now, think outside the bun just a little bit. Do you consider, I want you to consider movies, going to the movies, as entertainment, right? So in that sense, are there many or few substitutes? There are a lot of them. Reading books, taking a walk, raising goats, whatever it might be. There are a lot of close substitutes that fall into the idea of entertainment. And now even with COVID, and I would like to see this study after this, you can stay home and watch the movie instead of actually going to the movie theater itself. Prior to COVID, and I think this is interesting because this is the largest one I've ever seen, 3.36. 3.36. So if I think 3 is very elastic, this thing is off the scale. It's absolutely off the scale. Which, by the way, does actually explain a couple of different things. First of all, 15, 20 years ago, you could go to the movies for $2 or $3, right? Now movie tickets are what, 15? Right? About $15, something like that. But they do offer the matinee shows, don't they? Right? So you cut it a couple of dollars, that draws a lot of people in. A couple of dollars here or there makes a big difference. I'm not done yet. So when you go in though, but you start looking at the price of movie tickets, I read a study not long ago that said that if movie tickets would have kept up with inflation over the past 20 years, you should be paying about $50 for a movie ticket. All right, we don't do that. Why? Because if that price would have risen along with everything else, what would already have happened to movie theaters? Right? We're going to do something else. We're going to substitute over into something else. We're not going to go to the movie theater. So that's kept a cap on those prices. We can go, out on an evening and spend $30 to go, see the big screen. But so we're not going to pay any more than that. We'll go do something else. So if they can't get you coming into the door, where do the movie places get you? Where do they make their money? At the concession stand, right? They get you in there, then they charge you $50 for the bucket of popcorn while you're there. And that's how they go in and actually make their money. Right. So we'll finish this up on Friday. By the way, do not go yet. Hang on. I have a worksheet that I want to hand out to you. This is something new on Friday at the beginning of class. There's enough room that you can actually do your calculations on the worksheet itself. Again, if you do not show any work, you will not get any credit. The first three are done with the small equation, percentage change in quantity divided by the percentage change in price. Number 4 and number 5, you want to use the Clark elasticity formula on. And you do it exactly the same way that we have done the one in class. All right, and do the very beginning of class on Friday, no late papers will be accepted for any reason. All right, get out of here. If you have any questions, let me know.
Me? Yeah, you have this down. There's one. I've parked further back than I've been able to lately.
No. As long as you understand that. Okay, all right, very good. Because you'll come out with a different answer on this worksheet. So make sure you take it out before then. Yeah. Oh, I erased it. You got your phone?
Yeah.
Actually, did you write this down?
Yes.
In your notes. Okay, here's what I want you to do. Using this data, I want you to increase the price. No, increase the price. No, decrease it. I want you to decrease the price from $2 to $1.80. Right, and so using those same numbers, assume price decreases from $2 to $1.80. Okay, take a picture of that. And so I want you to calculate the elasticity of demand, and then tell me whether it is elastic or inelastic. Okay, very good.
Can you email it?
Bring it on Friday.
Okay.
That'll work. Yep. That makes sense?
Yeah.
Okay,
Thank
very good. Now, keep in mind, I do want to show you something. The Carlos when you're doing these, when you get to this step, well, when you're simplifying the numerator and denominator, take these out to 4 digits. So you should have had 0.1818 because it's a repeating decimal. This one should have been 0.1053 because your final answer is what the final answer is 1.6, 1.73, 1. So he was off by a 10, right, because of that. So take those out to 4 digits, then round it to 2, and you'll be good. Okay, yep. And if you want to send me a picture of it, that's fine. That way I can check it if you have questions.
Okay, thank you.